welcome for this part. Now, in this part, or so far we have discussed about the work, that is the first term of the work, energy and power. Now, in this part, we're going to discuss or we're going to start the second term, that is called the energy. And in this part also we're going to see that how or what are the different types of energy and what are the forms of energy. Now let's have a look. So, energy. Now, what is energy? This definition we have done in junior classes. The energy of the body is defined as the capacity of doing work. The definition is still same, but let's see what we have extra. So, since energy of the body is the total quantity of work done, therefore it is a scalar quantity. So energy is a scalar quantity and dimensions as that of work, that is ml square t minus 2, and its SI unit is joules and the CGS unit is erg. Let's see. So there are two types of energy we have, that is the kinetic energy and the potential energy. So what do we know? That the kinetic energy is half mv square. This we have done. This we already had done, and we will be studying in this thing that what is a potential energy. So two types of energy we will be dealing here, that is the kinetic energy and the potential energy. Now as we can see from the figure, let's say the cyclist at the initial point has some kinetic energy, and let's say if we assume that it has that much amount of energy so that it just reaches to the maximum point. Now what we can say, that at the initial point it has some amount of energy and it reaches to the maximum point. So therefore what we can say, that after reaching to maximum height or the maximum point, it stops over there momentarily because it won't be having any kinetic energy. This is what is our assumption. So therefore this diagram shows that after it will come down, while coming down it energy out. So this diagram is exactly showing that for the first part the kinetic energy is converted into complete potential energy, and now for the second part that is while coming down, that the potential energy get converted into kinetic energy. Now there are many forms of energy, that is this nuclear energy, that is because of the nuclear fission or fusion, electric energy that produces light, the potential energy, kinetic energy, this we have discussed, and chemical energy, thermal energy, magnetic energy. So there are many forms of energy. So this we have already done, that energy cannot be created or cannot be destroyed. So this is the thing, that it goes from one form of energy to another form. Now what is the potential energy? In junior classes we must have done that the potential energy is that kind of energy that comes only because of the virtue of its position. That is a position dependent. In the example of cyclist going up a hill, in that we already have seen that after reaching to the maximum height, now after reaching to maximum height and coming back, so what we have seen, that it will automatically going to gain kinetic energy. That means there was some kind of energy was there at the highest point, that we call the potential energy, that will going to get converted into kinetic energy. So actually the potential energy, we say that what is a potential energy? It is the change in the potential energy, or the difference between the potential energy between the considered point and the reference point. So we will only talk about the change in potential energy instead. So what we can say, that the change in the potential energy delta U as the negative of the work done by the conservative force, that is what we can write, delta U is equals to minus, that is the negative of integration f vector dot dr. going from initial to final, or let's say from A to B, where F is the conservative force. Now comes the mechanical energy. Now, what is a mechanical energy? Mechanical energy is the sum of the kinetic energy or the potential energy. So as we can see that there are examples: wind up toys, grandfather clock, pogo stick are the examples of mechanical energy, because they have given the mechanical energy is the movement of the machine parts. They have given the definition as the movement of the machine parts. So these are the example. So, and one more thing is that wind power uses mechanical energy to create electricity. Now after that we have the conservation of mechanical energy. Now, from work energy theorem, we have studies that the change in kinetic energy is the net work done. This we have done in the work energy theorem. So what we can say that if we consider that the work done net, that means the complete work done, if we say that there are forces which are conservative and the non-conservative, so what we can write, the work done net will be equals to conservative force plus the work done by the non-conservative force. This is what exactly we are going to get, that change in kinetic energy will be equal to the conservative work plus the non-conservative work. Now, so as we have already defined that the change in the potential energy as the negative of the work done by the conservative force, so therefore what we can write, that the change in kinetic energy is equals to minus of delta U. We have replaced the WC, that is the conservative work done, by minus signs of delta U. This is what was the definition of the potential energy change in. Now, so what we got, that the change in kinetic energy plus change in potential energy, this will be equals to work done by the non-conservative force. Now, if we have the situation like for the work done by the non-conservative force is equals to 0, that means there is body is not acted upon by the non-conservative force. So work done by the non-conservative force will be 0. So what we can write, that delta E will be 0. This delta E is equals to delta kinetic energy plus delta potential energy, or what we can write this as delta kinetic energy plus potential energy. This is the mechanical energy. So instead we are writing this as E. So therefore this is delta E. So thus if the non-conservative forces are 0, this is a mechanical energy. So mechanical energy of the system is unchanged. So this is the law of conservation of mechanical energy. So therefore what we can say, that if work done by the non-conservative force is 0, so delta U plus delta kinetic energy will be 0. So therefore what we can write, U plus kinetic energy will be equals to constant. So, or else what we can write this as, whatever amount of initial energy, after reaching to final point, the body will have that much amount of energy. This is what exactly it means. So this is the thing, that the initial potential energy plus initial kinetic energy is equals to final potential energy plus final kinetic energy. This is what exactly is the law of conservation of mechanical energy. So in the next example, a block of mass small m moving on a smooth horizontal floor with a constant velocity v0 collides with a light spring of stiffness constant k, which is rigidly fixed horizontally with a vertical wall. If the maximum force imparted by the spring on the block is F, then F, okay, we have to find out that whether F is directly proportional. We have to find out these relations, that which relation will going to satisfy this thing. So what do we know, that the spring applies, the force is equals to F is equals to Kx, that is the maximum force. So therefore if we will be able to find out what will be X, then we will be able to find out what will be the F. Okay, so what is the value? How we can find out the value of X? So now we can consider that the block is moving with constant velocity. So what is the kinetic energy? So kinetic energy will be half mv naught square, or what we can say that after striking the block, after striking the block after striking the spring will going to come momentarily at rest. Like if we'll consider that this is the spring and block is coming, and after hitting, so it comes to rest. That spring got compressed, block is over here, so force on the block will be kx. This is what exactly. So what we can consider that what do we know, that the delta E, or the change in the mechanical energy is 0, or else what we can write this, delta U plus delta kinetic energy is equals to 0. So after striking a block, now initial potential energy of the spring is 0, because after striking, so what will be the block will going to impart some amount of energy to the spring. So initial energy, when it has the natural length, so initial potential energy is 0, and the final potential energy will be kx square, half kx square, if we say that the x is the displacement in the spring, plus change in kinetic energy, final kinetic energy minus initial kinetic energy. So final kinetic energy after striking or after coming, so block will momentarily at rest after striking the spring, so therefore the kinetic energy will be 0 final. So 0 minus half mv naught square, this is the initial kinetic energy, so this will be equal to 0. So therefore what we can write this as, half kx square is equals to half mv naught square. So what we are going to get, v naught square is equals to, or else v naught square will be equals to k by m x square, or else we can write this as, because we have to find out x, so x will be equals to under root m by k v naught. Now we know that the force is equals to kx, so let's substitute the value of x from here, it will be k under root m by k v naught. So therefore this will comes out to be under root m k v naught. So therefore what we can say, what we conclude, that f is directly proportional to m, f is directly proportional to under root k also, f is directly proportional to v naught also. Then if we look at the example, all the examples are following, so therefore option D should be correct. Now let's look at the next example. What we have now, find the horizontal velocity of the particle when it reaches to a point Q. Assume that block to be frictionless. Okay, so as we have to find out the horizontal velocity when block will be here, we have to find out what will be the velocity of the block. So for this we can apply the conservation of mechanical energy, that means U final plus kinetic energy final is equals to U initial plus kinetic energy initial. Now what is the, if we talk about this final potential energy will be mg 0.5 plus final, if we say that the that velocity of the block is v at this point, so what will be the final kinetic energy, it will be half mv square is equals to initial potential energy, it is mg 1 because height is 1, and kinetic energy initial is half mv. Horizontal, there is no potential, there is no velocity of block over here, that means v is equals to 0 at this point. So what we consider that this will be 0 square, so what we are going to get, half mv square is equals to mg 1 minus 0.5. so what we are going to get, mg 0.5, and m and m will going to get cancelled, so what we are going to get this as So we're going to get V square is equals to 2G 0.5. This will comes out to be 20 into 0.5. So this will comes out to be 10, and this will comes out to be 10, and V square, V is will be under root 10 meter per second. If we look at the example, so it is okay. So under root 10 will comes out to be nearly equals to 3.13 meter per second. So if you look at the look at the options, so option C should be correct. So guys, in this part we have learned about the energy and different forms of energy, different types of energy, and also we have seen that the mechanical energy is conserved when we have the conservative force. Now, next part is the equilibrium. So for watching next part, stay tuned with us.